Hola, Michelle. This is your number 16. So, we're just going to go through the whole thing, even though you got some of it right. Okay. It says the table to the right shows the volume discounts offered by a company, where X is the volume of a purchase in dollars. I think that's what's tripping, or that might be what's tripping you up if you had trouble filling out this first answer of the piecewise equation. So when it says X is the volume of the purchase in dollars, that means the percent that you are paying, not the percent that you're not paying. So if we look at this little T chart, it says that the first discount is 2%. Well, your total percent, or your original percent that you pay at the grocery store, is 100% of the product. But if you get a discount of 2%, that means you're not paying 100% anymore. You're paying 100 minus 2. So you take that 100 and you minus 2%, and you get 98%. And then in math, we can't just write 98% in an equation. We have to take the decimal and move it twice to the left. So this decimal after the 8 moves twice to the left. And that's how we get 0.98. So for our piecewise function, if it says this volume 300 alligator x alligator 1,000, next to it we're going to put 0.98 and then something else. But if we look at our little piecewise function and look for the 300 to 1,000, here's the 300 to 1,000, and there's the 0.98 beside it. And then it's multiplied by X, because X is the volume of the original purchase. So if X is the original purchase, which is worth 100%, and you get a discount of 2%, that means you're only paying 98% of the original price. So to say 98% of the original price, you say 0.98, and then the original price is the letter X. And you keep doing that all the way down. So for the next portion, it says 5%. Well, 100 minus 5 is 95, but that's a percent. So if I make that into a decimal and get rid of the percent sign, I take the decimal that's to the right of the 5, it's pretend, and I move it left twice. And you get 0.95. So this is saying that you're paying 95% of the original price, and the original price is X. So it means if the original price of the item is in between $1,000 and $3,000, then you get a discount of 5%, and you're really only paying for 95% of the original product. If your original product costs in between $300 and $1,000, then you get a 2% discount, and you're only paying 98% of the original price. Let's fill out the rest of the table. This one says if your original product is in between $3,000 and $5,000, you get a bigger percent discount, and it's 6%. So we say 100 minus 6% is 94%. Then we move our decimal over, 0.94. So that means we're paying 94% of the original price. Okay, then lastly, it says X is since X is bigger because the alligator is eating the X on this very last sucker, it says 5,000 is less than or equal to X, or you can say X is bigger than or equal to 5,000. That's another way that you can write this last sucker. So what that means is for any purchase above $5,000, you get a 10% discount. So 100 minus 10 is 90%. And when we write 90% in math without a percent sign, we take the decimal and we move it twice to the left, so 0.90, and then an X. Okay, so this means that you're paying 90% of the original product. Yeah, okay, so let's look at part A. It says X approaches 1,000 with a little negative. Well, that little negative means to the left. Okay, so let's find on our part A what numbers are to the left of 1,000. Okay, well, first let's find 1,000. Here it is right here. It's either on the third row or it's on the second row. Well, the second row means we're in between 300 and 1,000. The third row means we're in between 1,000 and 3,000. Well, what numbers are to the left of 1,000? Because that's what part A is asking for. Numbers to the left of 1,000 are not 3,000, but maybe 300. Yeah. Okay. So 1,000 fits into this. Left of 1,000 fits into this if 300 less than or equal to X less than 1,000. Okay? Directly to the left. So to figure out what the limit is, we're going to take this 1,000 and we're going to plug it into the equation that describes the numbers to the left of 1,000. So if we go back up to our equations, there's 1, 2, 3, 4, 5. But the if part describes the left of 1,000. And since numbers to the left of our 1,000 are like 900, 800, 700, 600, 500, 400, 300. Anyway, that means it's in between 300 and 1,000. So we're going to look at this second equation, 0.9x. And we're going to take that 0.98x and we're going to plug in 1,000 for the letter X. And that dot is just a mistake, my bad. And 0.98 times 1,000 means 980. So to figure out what the limit is, first you have to figure out the number that they gave you, where it belongs in the if statement. So let's look at this part B. It says X approaches 1,000 with a plus. That means from the right. So let's look up at the if statements, the ifs, to see which one of these means directly to the right of 1,000, as in bigger than 1,000. Well, there's lots of numbers that are bigger than 1,000. 5,000, 5,000, 3,000, 3,000. All of these numbers are bigger than 1,000, but we need to know which numbers are directly after 1,000, like directly to the right. So, yes, 5,000 is bigger than 1,000, but it's not directly to the right. It's not directly after. So when I'm talking about to the right of 1,000, I'm talking about 1,100, 1,200, 1,500, 2,000, 2,500, 3,000. Those are the numbers that I'm talking about. Whatever is closest to 1,000 on the right. So I'm not going to look at this 5,000 equation. It's too far away. I'm not going to look at this 5,000 equation. It's too far away. I'm going to look at this third equation that says if X is in between 1,000 and 3,000. because that represents all the numbers directly bigger than 1,000. So I'm going to use this 0.95x, and we're going to plug in whatever x approached at the bottom, which is 1,000. And when you put that in your calculator, you should get 950. Okay, now part C says, what's the limit of just 1,000? Well, this is what Hector said the other night. The only way the limit exists is if the left and the right match. But if we look at the left and the right of 1,000, the last two limits, they're different, 980 and 950. So we're going to say this limit does not exist because the last two don't match. If the last two would have been 980, then this one would have been 980. If the last two were 7, then this one would be 7. But since the last two are different from each other, this one does not exist. Okay, let's keep going. Now it says part, I think we're still in B, but it says limit as x approaches 3,000 from the minus, and minus means, in the air, means left. So we're looking for numbers directly to the left of 3,000. So let's look up here in our equations for what describes left of 3,000. Well, 0 to 300 is left of 3,000. 300 to 1,000 is left of 3,000. But we want what is directly left of 3,000. So even though these first two are left of 3,000, we want to know what's directly left. So a number directly left of 3,000 is 2,999. That would fit in this third sucker. So we're going to use this third sucker, which is 0.95x. And then we're going to plug in whatever x is approaching. So not 1,000 anymore. Now we're approaching 3,000. And then I think that gives you 2,850. Okay, so now the next one says 3,000 to the plus, and plus means right. Okay, so a number directly to the right of 3,000 is 3,001. So let's see, where would 3,001 fit? It would fit in this, in between 3,000 to 5,000. So we're going to use that equation, 0.94x. As in 0.94 times the number that we're approaching, 3,000. And let me see what that gives you. Whoa. Oh, I did that wrong. I got 2,820. Woohoo. Okay. Lastly, it says, what is the limit as you just look at 3,000 straight on? Well, that means you have to look at both of the previous two answers. And if they're the same, that's the answer. If they are not the same, it does not exist. So, since they are not the same, does not exist because you don't match. Okay, so let's go over this again. I think you're okay with how to get the whole does not exist, but at the very beginning, to get these equations over here on the left, we took 100 and subtracted our discount. Then we moved the decimal over twice. And that's how we got these equations. Then, to figure out which equation we're looking at, we look at the x approaches on the bottom of the limit, And if it says X approaches 1,000 with a minus, that means left. So a number to the left of 1,000 is 999. And then you would look up here in the if statements to figure out, where does 999 fit? And it fits in between 300 and 1,000. So we use that 0.98 equation to plug our number into.